Hi, in this video I will show you how to create some inter-VLAN routing. So we have a layer 2 switch, we have more than one VLAN, and we want to route between our VLANs. This is a very important topic on a CCNA exam. In a real-life situation we would use a layer 3 switch in most situations, because it's not as expensive as it used to be, but still a router on a stick, because that's the name for this technology, is a very popular solution. So let's take a look. I prepared a very simple topology with 4 PCs and 1 switch. I want to create 2 VLANs, VLAN 100 and 101, and I want to make sure that I can ping PC 0, for instance, from PC 1. I cannot do that using this switch only. Why? Because this is a layer 2 switch only, a layer 2 device. So it cannot route any packets. Switches work with MAC addresses. Okay? So in this situation, in this scenario, we will need a router, and this solution is called a router on a stick. But first let's take a look at the switch, because I have not set up the switch yet. So let's take a quick look and make sure that everything is in place. This will be a very good way for you to review some VLAN and switching concepts as well, because we'll go through creating VLANs, assigning ports to a VLAN, and so on. So I go to a global configuration mode, and first I will create my VLANs. I will give it a name, let's say marketing, and the VLAN 101, let's say name HR. To verify, I type show VLAN, and I can see that these 2 VLANs were created on this switch. Okay, so now I can assign some ports to these VLANs. Okay, I have 4 PCs. This one is F02. I should type 2 commands. First, to hard code this port as an access port, so it means that this switch will not try to negotiate a trunk with the other side. It's a very important security command. And second, this line will assign this port to VLAN 101. Okay? There is one more that we could type. That's spanning tree port fast. Okay? This is a command that will, in a way, disable spanning tree on a port, and will allow this PC, for instance, to get an IP address much faster. If you do not understand this concept, please go back to your spanning tree topics and try and read about spanning tree again. Right. Good. So we have our first port assigned. The second one is F01. That will be in VLAN 100. Let's put spanning tree port fast as well. The next one is F04 and F03. 04. Good. Let's verify. I have VLAN 100 and 101, and I have some ports assigned to these VLANs. Good. So right now I should be able to ping PC2 and PC0. Okay, it's working. Should be able to ping PC3 and PC1 because they are in the same VLAN. Will I be able to ping PC2 and PC1? No. Why? Because they are not in the same VLAN. Take a look, they are not in the same subnet, okay? Because VLAN is a subnet, okay? So we need a router, okay? We need a layer 3 device to route between these VLANs, okay? So let's take a router. We'll connect it with a straight through cable. Let's use ports, let's say 10 and 00 on this side. Let's label it. Good. There are two steps to make it work. First of all, on the switch, we have to set up this link as a trunk. Okay? Why? Because we are going to send more than one VLAN. It's one VLAN 101 and 100. Okay? And maybe some more VLANs. So we have to make sure that this is a trunk. Okay, so let's start on the switch. Okay, we need to hard code it as a trunk. Okay, good. So when we type show interfaces trunk, we will see, we can't see it because the other side is down, so let's go to this router and just type no shut for now to bring this interface up. Okay, let's go back to this switch. Okay, so this is our trunk. Okay, so we can see that F010 is a trunk. Okay, it uses 802.1q, the standard encapsulation, and our native VLAN is 1. For the security reasons, we should put our native VLAN. We should use another VLAN for our native VLAN, but this is a lab regarding inter-VLAN routing, so we can leave it for now. Okay, good. So this is step number 1. We have to make sure that this link is a trunk. Okay. Now, on router 0, we have to create 2 sub-interfaces, because this router will be responsible for routing the packets between VLAN 100 and 101. The way it's going to work is like this. Let's say this is our packet. Okay, and let's say that PC2 wants to send this message to PC1. So from VLAN 100 to 101. So this packet will go to this router. This router will route it back to PC1. PC1 will send it back to the router, and the router will send it to PC2. Okay? If we had a layer 3 switch, so it means a switch and the router in one box, it would work like this. Okay? But for now, That's how it's going to work. That was a powerful animation. Okay, good. So, a few things to do on our router. First, let's go under the interface, and here we have to make sure that there is no IP address assigned. We do not need an IP address over here. Okay, what we need to have is two sub interfaces. Okay, let's do it like this. Most people will create a sub interface that matches the VLAN number, but it does not have to be like this. On your CCNA exam, they will assume that that's the case, so be careful. Okay, and we need to give an IP address. An IP address from the range that this VLAN belongs to. So it will be 192.168.100. Let's say I will say 254. Okay, this one will be 192.168.101.254. Okay, so thanks to that, it's pretty easy to see that, oh, this is VLAN 100 and this is 101. It does not have to be like this, but it's a good practice to set it up that way. Okay, the way we do it, we type 0 dot and a sub-interface number that we want to create. Okay, so we want to create number 100. Okay, and here we have a few commands to choose from only. We have to type encapsulation .1q and what is the VLAN that we want this sub-interface to be assigned to. Okay, again we have to do that because this number does not have to match this number. Okay, so Cisco allows you to say sub-interface 200 and VLAN 25. It does not make any sense, but it's your choice. Okay, so that's what we have to do, and here we have to put our IP address. Okay, we don't have to type no shut because the port should be up, but not cause any issues. Let's create 101. Good. Let's type show IP interface brief. Okay, we can see we have two sub interfaces. Okay, when I type show run interface F00100, Packet Tracer does not support this feature, so let's type show run. Okay, we can see these two sub interfaces, encapsulation 101 and 100. Okay, and we're ready to go. And it worked. Okay. Packet Tracer has a very nice feature that is called simulation mode that allows you to see how this packet travels. Okay, so let's take a quick look. Okay, so take a look. It will go to the router. The router will send it back to the switch. PC1, switch, router, switch, PC2, deliver. Thank you very much.